So I'm Gayal Dassanayake, a senior software engineer at WSO2. Today we are going to talk about the Ballerina CLI and how you can use the Ballerina CLI and how you can extend the Ballerina CLI in order to write powerful integrations. So in this talk, we are going to go through our several topics. The first one being the Ballerina CLI. What are the commands that we have in the Ballerina CLI and what each command does. And then we are going to talk about the extended CLI tools, how we can add more commands to our CLI chain, and how we can use those tools to write different integrations. And then we are going to talk about one such tool that we are going to that is not packed in the Ballerina distribution, but we can add it later to our command set, and then we'll go through a demonstration of how we can use that in a real world scenario. And then at last, we have the newest feature that we have in the Ballerina CLI, integrating tools with the package build. So then at the end, we can discuss any questions that you have, and we can provide answers. So Ballerina CLI, I would like to think it as a toolbox. So this is the go-to place when you are coding in Ballerina to create projects, to compile and run projects, maintain projects, and even generate source code for different integration purposes. So there are four different categories of commands in Ballerina CLI. The first one being the core commands, and then we have the package commands, update commands, and other commands. So we'll go through each of them in the next slides. Also, before we go through each of these commands, I should mention about the Ballerina low-code capabilities as well with the Ballerina VS Code plugin. So it provides an amazing set of capabilities. You can build packages, get overview diagrams, get architecture diagrams, and there's also a cool data mapper. Definitely, you should check out that as well. So the first type of commands is the core commands. So these commands are helpful when you are interacting with Ballerina programs. So the first command that we have under this category is the build command, which will compile and create an executable jar, which is standalone so that you can run it anywhere. And then you have the run command, which not only compiles but also executes the Ballerina program. Then you have the test command. So Ballerina has a built-in test framework which can be used to validate your source code. And with the bell test command, you can run all the tests that are in the Ballerina project and even get test reports and code coverage reports and all that. Then we have the doc command, which will automatically generate you the API documentation for your package so that you don't have to change the API documentation when your APIs get changed. Then we have the Bellpack command, which is useful to create a Ballerina source archive with the extension of .bella so that you can share this code in the Ballerina center so that other developers can use your package as a dependency. Then we have the package commands. So package commands are helpful to create and manage and share packages. And under this category, the first command that we have is the new command, which will help you to create a new Ballerina package. So there are three different templates that you can use to create a package. You can use the main template to create a package with the main function. And if you're creating a service, you can use the service template. And if you're creating a library, you can use the lib template. And then we have the push command. Once you pack a package using the bell pack command, you can use the bell push command to push it to Ballerina Central or any other different repository that you want. Then we have the search command, which is helpful when you're trying to find different dependencies that match a keyword. So you can do bell search and provide a keyword, and it will list all the packages that matches the keyword from the Ballerina Central. We have the graph command, which is really helpful when you're trying to resolve any dependency resolution problems. We can just do a bell graph and it will print out the entire graph of dependencies, including all the dependency versions that we have picked and the interdependencies of each of these dependencies. We have the deprecate command next. So deprecate command will allow you to deprecate maybe an entire package or even a specific version of the package. Let's say you have a vulnerability in one version, you can just deprecate that exact version and it will not be picked as a dependency when another user package is trying to resolve its dependencies. Then you have the Balsam command. This is an experimental but very cool feature. Let's say you change an API. Let's say you add a new API to a set of functions. Now, if you do a Balsam command, it will suggest that you should go to a minor version and not a major version or a patch version. So just because you have just added a new API. So similar to that, you can use the same command to get a suggestion on which version you should have in your package next. Then we have the update commands. So update commands are responsible for managing the Ballerina distribution installations locally. So we have the dist command, which has a set of subcommands, pull command, update command. So those commands will help you to pull and pull a specific version of distribution, and you can update to the latest patch version of that. Then you can list all the distribution versions that are installed locally, and you can, with the use command, you can switch between different versions, and using the bell dist remove command, you can remove an entire distribution from a local machine. And then all these things are done using the Ballerina update tool, and this update tool can be updated using the bell update command. So then we have the other commands. So under this, a set of commands are specially defined to develop integrations. The most famous one being the OpenAPI tool. So the OpenAPI tool allows you to generate Ballerina services and clients using OpenAPI definitions, and the OpenAPI definitions using Ballerina services. And then we have the GraphQL command, where we can generate Ballerina GraphQL services from a GraphQL schema and vice versa. And we have the async API command, where we can generate a Ballerina listener from an async API definition. We have the gRPC command, where we can generate Ballerina gRPC clients or services from a protobuf definition. And then we have the persist command. So persist command is helpful when you're interacting with the data store and you're trying to persist your data. But the specialty here is you don't have to deal with the data store specific syntaxes here. You can just use Ballerina syntax and Ballerina data types to interact with the data stores. So currently it supports MySQL, MS SQL, PostgreSQL databases, and Google Sheets. And the newest addition is the Redis support. Then we have a set of other commands. Bell format command will help you to format your code according to Ballerina formatting guidelines. And there's Bell version command, and Bell profile command will help you to profile your runtime and get a flame graph output. And then we have the Bell tool command. So I will not discuss what Bell tool command is, and we'll go through in the next couple of slides why we need the Bell tool command and what are we using that for. So now we have a clear understanding of what are the all commands that we have in the Ballerina distribution that are installed by default. So if I say that Ballerina provides the capability to have even more tools, the obvious question is why? Why do we need even more tools? So as all of you know, Ballerina is a programming language specifically catering to integration purposes. So that means we need to serve a lot of technologies and work with a lot of different domains easily. So in order to facilitate that, Ballerina needs a lot of different CLI commands. However, it doesn't make sense to pack all these commands in the Ballerina distribution. So some tools might be used by say a subset of users who are working with only a specific domain. So for other users, it might not make sense to have them in the Ballerina distribution. So that is why Ballerina has the capability to add more and more tools into the CLI according to your requirement. So I mentioned a couple of slides ago about the Bell tool command. So Bell tool command is the tool, the command responsible for managing all these external tools that we have installed in our system. So to get a better understanding, let's go through a demonstration and see how this is happening. So the Bell tool command has a set of subcommands which allows you to manage all these commands. So the first one being the Bell tool search commands. It allows you to provide a keyword. So I'm giving this keyword health, and it will list all the commands that are related to healthcare integration. So right now we only have one, which is health tool, and we have the version 2.1.2, the latest version. So if you want to pull this, you can just do Bell tool pull and specify the tool ID, health in this case. And if you don't specify a version, it will pull the latest version. So this health tool is designed to develop care integration, typically work with the file protocol. Someone who is working in the healthcare domain, this can be very helpful. Since this bigger package, it will take some time. So once you have installed the tool, use the bell tool command to list all the tools that are installed in your local machine. Let's give it a while. Okay, now the health tool is installed. If you do a bell tool list here, it will show that the health tool is installed, and there's an asterisk mark in front of this to show that we have installed the 2.1.2 of the health tool. So if you want to install exact version, you can just specify the version. Let's install the version prior to this, 2.1.1. Once again, it will pull that exact version. I'm trying two different versions so that I can show you how we switch between the different versions and how you can different versions of the same tool easily. Now this version also has been installed, and as you can see, once you pull a specific version, it will be automatically set as the active version. So if you do a bell tool list now, there are two different versions of health, but the active version denoted by the asterisk is 2.1.1. Let's say you want to switch between different tool versions. We can use bell tool use command for that, and you can specify the tool ID and the version that you want to switch to. So now the health tool 2.1.2 is the active version. So if you want to switch back, then use once again the tool use command. So let's say you want to remove a specific version of the tool. Then use bell tool remove, once again specify the tool ID, and you can specify the version here. So now if you do a bell tool list, it will show only one version. So if you do a bell help here, you can see in the tool command section, we have EDI tool and the health tool both installed in our system. So if you want to remove the entire health tool, you can use bell tool remove and just provide the ID without a specific version. So this will remove the entire tool. So now if you do a bell health, you can see that the health command is no longer there, only the EDI command will be shown here. So if you do a bell tool list once again, only the EDI tool is there. So this is how we can manage external tools with the bell tool command. So now let's look at the ecosystem of CLI tools that we have as extended tools. So we have the EDI tool that is used to work with the EDI files in Ballerina. We will explain and we go through into deep details regarding this EDI tool in the following slides. And when then we have the health tool that we just use, which is helpful for developing healthcare integrations. We have the copybook tool, and we have the scan tool, which is the Ballerina static code analyzer. This is not released yet, but it will come soon. And also there is a set of other tools as well. And this list will continue to grow as our integration tool chain will continue to grow. So now that we have an understanding about what these extended tools are and how we can manage them, let's look at one example of these tools so that we can understand how Ballerina is really helpful in dealing with the related integrations of different commands. So here we are going to talk about the EDI tool. I know that most of us are not familiar with what EDI means, so I'm going to explain what that means in the next couple of slides, and then we can go on to how see how Ballerina is involving in this process. So EDI stands for Electronic Data Interchange. In simple terms, it's a standard data protocol for businesses to exchange different documents. Usually businesses exchange a lot of different documents in their day-to-day transactions. So it may be invoices, purchase orders, quotation requests, and even shipping orders, and all these things. So let me explain why we need EDI for this document exchanging purposes. So for that, I'm going to go through a simple example where company A will want to purchase a set of items from the company B. So what can usually happen is the company A will generate a purchase order, and some person from that company A will either mail or fax or perhaps email that purchase order to the company B, and the company B will, someone from the company B will get that purchase order and enter data into their system, and they'll generate an invoice, and that generated invoice will be sent again back to the company A using email, fax, or traditional postal mail, and then that will be recorded in the company A's internal system. So even if you use email, which is a sort of a newer technology, still someone will have to receive that email and enter the data manually. So this is where EDI comes in. So with the help of EDI, company A's internal system can share a document, let's say a purchase order, as a EDI document to the company B's internal system. And with minimal human input, the company, the internal system will be able to generate an invoice, which can be sent again as an invoice EDI document to the company A's internal system. Obviously, the benefits of this are reduced cost, and the processing speed will be vastly increased, and also due to the minimal human input, the error percentage also will get reduced. So let's look at how Ballerina is getting involved with this EDI technology, so that people can develop integrations with EDI faster. So before that, there are different types of EDI standards. There is X12, EDIFACT, ESL, and a lot of different standards. So these standards are created by different organizations for different purposes and different industries. Uh, and also for each of these standards, let's say X12, it has a set of schemas that it has defined for different documents. So X12 might have a schema for purchase orders. It also might have a schema for invoices. Likewise. So what Ballerina EDI tool does is it converts these documents or sort of the schemas into a standard Ballerina EDI schema. So once that is converted, all these schemas are converted into a Ballerina schema, we can use the Ballerina EDI tool's code gen command to generate Ballerina records and parser functions. Or we can use the Ballerina libgen command to generate an entire package that contains Ballerina records and parser functions as well. And on top of that, we have the utility methods and also a REST connector as well. So let me go through a simple Ballerina EDI schema so that you understand what this EDI schema will look like. So this defines how a purchase order document should look like. So this is a sample schema, very simple that I have created just to demonstrate to you. So this is a purchase order schema, and we have several segments. We have the header segment with the code HDR and fields, order number and date, and we have the supplier segment with the SUP code and the name and email fields, and we have the items segment with the item ID code and the quantity. So you can see that here in the quantity we have mentioned that the data type is int. So that means if you don't specify the data type, it will automatically assume that the data type is string. And we have the max occurrences field, which is -1 in this case. So that means we can have as many items as we want in this purchase order document. And also there are different delimiters. So to mark the end of a segment, we have used the tilde mark, and to mark the end of a field, we have used the asterisk marks as well. So now let's look at the document that adheres to this EDI schema standard. So this is an EDI document which adheres to the previous schema, and let's go through each of these fields and to understand how an EDI document is composed. So the first field we have is the header with the code HDR and order number and date, and we have the supplier field with the name and email, and we have items, a set of items, each with the item ID and the quantity. As you can see, each of these fields are separated by an asterisk marks, and to denote the end of a segment, we have used the tilde mark. So now we have a rough idea of what EDI is and how Ballerina is involving in this generating of EDI, processing of EDI documents. So let's now look at a demonstration so that we can understand better how we can use this EDI tool to write EDI integrations. I hope you can see my screen. The VS Code. Okay. So we have this X12 set of X12 schemas. So one is the standard schema for the invoice, and the other one is for a purchase order. So as we went through in the previous slide, we can't directly handle these X12 schemas. So what we need to do first is use the EDI tool to convert these into Ballerina standard schemas. So we can do this with the sub command convert SQL schemas with the input as the invoice in this case, and the output as the Ballerina schemas. I'm going to name the output file as invoice.json. So it will convert the schema into a JSON that adheres to the Ballerina standards. So if I format this document, you can see that this is a much complicated document than what we went through in this previous example, because this is a real world scenario, and this has a lot of fields that is required by the real purchases orders. So similarly, we can generate for the purchase order as well. Purchase order. So now we have two different Ballerina schemas for the invoice and the purchase order. So now that we have these schemas, we can generate a package with all the utility methods that we need. So for that, I'm going to use the Bell EDI libgen command. So since we are generating a package, we have to specify the org and the name with the dash p flag. So here, since these two invoice and purchase order schemas are related to aerospace industry, I'm going to use aerospace as the org name. And the package, let's name it inventory. And the input should be the Ballerina schemas. The output is, I'm going to output the generated package in the current working directory. So now we have generated this brand new Ballerina package using this schema. So if you go to the module section, we have two different submodules, in invoice and in purchase order. So if you go to one file, you can see that here this function will allow you to pass an EDI document as a string, and it will return a Ballerina record that represents that EDI document. And this function does the other way around. So if you pass the corresponding Ballerina record that matches the EDI document, it will return the EDI document as a string. So now that we have this utility package, we can just pack it and push it. Sorry, I just need to check in here. So we can just pack it and push it to a repository so that we can use it from another different package to get this functionality. So I'm going to bell push, but I'm going to use the repository equals local flag. So what it does is it will push to the local repository inside our machine. So this local repository is really helpful when you're trying to develop something, because it sort of imitates the Ballerina central functionality. So you can push it to the local repository and test. And once you are completely confident that this package is finalized, you can send it to the Ballerina central. Okay. Now we have packed and pushed the package. Now from a user's point of view, we can use this. So I have created this sample package here. So in this scenario, what we're trying to do is I'm going to read the sample purchase order here. This is the purchase order. So you can see that we have the items recorded here, and we have the all the company name and the address and all these details. So what I'm going to do is I'm going to read this purchase order as a string, and then I'm going to load it to a record using the inventory package that we just generated, and then we can manipulate the Ballerina record easily and convert it into a invoice, and we can save it as an EDI document. So that's what I'm going to do here. First, I'm reading this as a string in the IO module. So now we can use the in purchase order package module, and with the from EDI string method, we can convert this into a record. This will be of record type in purchase order. So now that we have the purchase order record, we can convert this into a invoice by extracting the details from this record itself. So since we have limited time, I have created this utility method already. So we can use this utility method and convert this into an invoice. I'm just passing the purchase order. And what you get is an invoice. So now we can convert this invoice record into a invoice EDI format. That also is done by the invoice generated package to EDI string. And I'm going to just pass the invoice record here. So perhaps we can save this as a EDI file as well. Try the path. I will save this. So now, if you run this program, so now it should generate this invoice.tdi. So here is an sample invoice that we have generated from the purchase order that we had. So as you can see here, we didn't have to do anything with the, we didn't have to process any strings. We didn't have to pass the EDI. We just had to generate the necessary utility functions using Ballerina, and we just had to deal with Ballerina records, and we just handled EDI really easily. So now we have a fair understanding of all the CLI tools that we have in the Ballerina command toolchain, and then we went through how we can extend all these tools using by adding more and more commands, and why we need that also we discussed, and we went to the demonstration as well. So the next topic that we have is integrating tools with the package build. So let me explain first what this means. So let me take an example. So let's say there is a third-party service uh, that is which has an OpenAPI specification that is available. So you can get this OpenAPI specification and generate a client for that using Ballerina, which is very easy. You can use the Ballerina OpenAPI tool and can generate the OpenAPI specification for that. Sorry, you can generate the Ballerina client using that OpenAPI specification. So that is very easy, and that is already there. So that's not a problem. However, let's say the OpenAPI, the third-party service got changed, and as a result, your OpenAPI specification is different now. So now when you do now your client might not be even compatible with the original service. So this can be a problem. So how integrating tools with the package build helps there is we can just integrate a tool into your package and if you do a bell build, when you do a bell build, automatically all the client source code, in this case the OpenAPI client source code, will be generated, and it will be compiled at once as well. So even if you do a simple change in your OpenAPI specification, next time you do a bell build, the client code will be again changed. So this way, it will always have one single source of truth, uh, and every time you do a bell build or even a bell pack, your source code will be regenerated to match that OpenAPI specification. So currently, only the OpenAPI and the Persist tools support this, but soon other tools also will follow this method. So now we have an understanding of why we need this. So let's look at how we can integrate tool into our package. So this entry that I have here is a sample of the Ballerina terminal that we have in a normal Ballerina package. So it has all the org name version fields. So what we need to do is we need to add another entry to integrate a tool into the package. So there, in this example, I have tried to integrate the OpenAPI tool. So it has the entry tool.openapi, and if it is persist, it should be tool.persist likewise. So we in this array, in the array table, we have the first field ID, which is a unique ID to identify this entry, and then we have the file path. It should be in the OpenAPI case, OpenAPI specification that we are trying to generate the client to, and then we have the target module. Where should we put this generated source code? Should be specified here. In this case, we are putting the generated source code in the delivery submodule. And also there can be different options available. So in this case, for OpenAPI, there are a set of options like mode, license, status code binding, and tags, and there are several other options as well. So if you note here, this tool.openAPI is a not a table but an array. So that means we can have multiple tools, multiple OpenAPI specifications integrated to this package, and that way we can generate multiple OpenAPI clients into different modules of the same package. So in this example, what I have done is I'm going to generate a client for the delivery os.ml file, and I'm going to put it in the delivery module, and I'm going to generate pricing os.ml using the pricing os.ml file. I'm going to deliver another client, and that will be residing in the pricing module. So once again, let's go through the demonstration so that you understand this clearly. So let me explain what I'm going to demo first. So we have this hospital service, which is a already written Ballerina service, and with the Bell OpenAPI command, we can easily generate the OpenAPI specifications for this hospital service. And once we have the OpenAPI specification, then comes the new part where we do the client generation with the new integrating tools with the package build. So we can create a hospital client package, and we can integrate the OpenAPI specification by specifying those fields in the Ballerina TOML. So once we do that, if we do a bell pack or a bell build, it will automatically generate the client source code automatically, and it will pack it at once as well. So now that we have generated the client, we can use it to consume the hospital service. A third-party user can use this hospital client and interact with the Ballerina hospital service package service very easily. So even if there is a change in the OpenAPI specification, you just have to do a bell build, and the client will be regenerated with the updated client. I'm going to share my demo code once again. So this is here we have a service called hospital service. This is a package, and under this we have two different services. So the first one is the hospital service, which handles all the basic functionalities of hospitals, like managing patients and having their medical records. And then we have the support service, which helps us in managing the support functions, like handling the employees and handling inventory systems. So there are two different services in this package. So with the help of the OpenAPI command, we can generate OpenAPI specifications for that. So I'm going to do just that. We as the input, we need to pass the service file. In this case, hospital service bell, and as the output, I'm going to generate the OpenAPI specification in this resources field. So now we have generated the OpenAPI specification here. You can see all the fields are generated here, and all the endpoints are listed here. You can do the same for the support service as well. So we have the OpenAPI specification for the support service as well. So now that we have these OpenAPI specifications, we can create a client and integrate the OpenAPI tool to that. So I'm going to build a new package with the bell new command, bell new, and I'm going to name it hospital client. And I'm going to use the library template because this is going to be a library package. So this is the hospital client. I'm going to delete these tests, so we don't need them. And since we are going to generate source code, we don't need any source code. So here is what we are going to specify what tools we want to integrate. So tool.openAPI, and I should give an ID which is unique. And the file path corresponds to the resource that we are using to generate the client, in this case the OpenAPI specification. And the target module. So in this case, this target module is where we are going to generate the client. However, I'm not going to mention this target module here because I want to generate my source code into the default module of the Ballerina package. So if you don't specify a target module, it will automatically generate the client in the default module. So instead, I'm going to use the mode options. One of the options, I'm going to pass license as an option. So all the source code will be under this license now. So similarly, we can add the support open API specification as well. Let's say the ID is support. Or once again similar to the previous one. You have to specify the target directory, target module. Let's say it's support. Okay. Now you can just do a build or bell pack here. Yeah, I think there is an error. I have given the invalid given an invalid file path. Let me redo it. So now we have generated all the client source code that we need. So we have the client that deals with the hospital service, and also different data types that we need to interact with the hospital service and via hospital client. And also for the support OpenAPI specification, we have another client and also different data types generated as well. Okay, so now that we have the client, we can just do a back push. I'm going to push it again to the local repository. So now we have pushed it to the local repository so that we can use this client in a different example. So I have already created a sample package. So where we are going to use this hospital client in order to interact with the hospital service. The scenario is like this: a patient comes in and he wants to register into the system of the hospital, and he's diagnosed with the disease. So we want to add a medical record as well. So first, I'm going to import our client and create a client instance of that. Provide the service URL. Okay, now we have the client. We can insert the patient entry here. So I'm going to first create a patient entry. So the fields of the patient entry should be first name, last name, date of birth, and gender. Now we can insert this patient entry into our system using the client. Client. So all these methods are auto-generated. So we can use one of these methods. In this case, patient's post method. And retrieve the patient entry from here. So now what we have to do is we need to create a medical record once again. So for that we need to just create a medical record entry. Once again, the field should be patient ID, date, and description. So once again, similar to previous case, we can just use the client's methods. So you can generate new entry for medical record, and you can just, let's say I'll just add a log that saying that this process is successful. So now if you start the Ballerina service, we have the hospital service. I'm going to run it. If I do a bell run, this should insert all these medical records correctly. So now we have created the medical record. So even if the hospital service gets changed and the OpenAPI specification is getting changed, we can just regenerate the hospital client very easily, because we just have to do change the OpenAPI specification and just do a build, and the source code will be regenerated again. So that marks the end of my demonstration and also the presentation. So once again, if you have any questions, you can raise in the Discord channel, and we have all this documentation. We have a well document. We have documented everything very well in our Ballerina CLI documentation, and you can refer to different integration tools like EDI tool documentation and help documentation if you want. So yeah, thank you very much for everyone for joining.
Thanks, everyone. And thanks, Gayal. And if you want to join any of our community channels, I have dropped all the links on the chat. So, yeah, thanks again for joining.